Okay. Good afternoon. It's final call, boarding completed. This is, I know, I'm aware that I am the last person between you and the closing keynote and the free weekend. So I greatly appreciate that you're here with me, willing to participate in this fascinating talk about time and time zones and how we do have all those falsehoods, assumptions about managing time in the computer systems. Obviously, as you know through, you know the drill, there is a Slido where you can ask questions, and I will cover them at the end. This is a short talk, so we will not be interrupting. My name is Jakub Marchwicki. I know it's very popular to say a few words in Polish, so Dzień dobry, Kraków. I do work remotely in Kasumu, and I also run a conference in Poland called SACFOLD. So we are all engineers, so we'll run it by example. Imagine a very small snippet of XML code. It can be whatever JSON, whatever transport, but it's a part of a message for integrating to system. To give you more of a context, it's about bus timetables, and this particular snippet tells you the time when the bus leaves this particular stop. It's obviously a slightly bigger message with all the routes and all the stops combined, but we'll be focusing on this very simple, on this very single, as a single point. As you might notice, it's kind of weird, isn't it? Because when we think about timetables, we are thinking about the time a bus leaves. We don't really think about dates, hours, because the timetables is pretty much every day the same. Well, it isn't, but we'll get to that. So, what is this, like, end of 19th century? The question can be put more, what's the time zero? Like, where is the beginning of time in the computer system? And at this moment, most of the people says, well, that's obvious, it's 1st of January 1970. It is, until it isn't, because that's only a part of an epoch which we know. It's for Linux, for Java, for PHP, but there are some other beginnings of time. For example, Postgres database starts with the 1st of January of 2000. And there are some other dates, like Microsoft.NET likes the first year of new century, which is all fine. And there's also a Microsoft approach, which is pretty much similar to what we have here. Though this weird date isn't exactly from Microsoft, it's still from Java. Because if you go to new date and create a date, and as you create a date, you can pass over a long variable which tells you the number of seconds since starting of the epoch, which gives you a 1st of January 1970. That's all fine, we all know it. However, if we overuse, or if we take the already deprecated API and tell Java to not count a year and month and date, well, we'll zero it. We'll get pretty much what we had before. We'll get 1899. Okay, so now it's fine. We know from where the data is coming from. So how it's derived in seconds, as we know, like we have this timestamp with this timestamp idea that any date can be derived as number of seconds from the beginning of the epoch. So for 1970 and everything that's beyond that, that's easy, that's positive. But also the timestamp can be negative, and that's something that we very often oversee. So what I'm trying to show you here, and what we are having problem with at the moment, is that people tend to overuse the timing information and get a little bit fuzzy. This is mostly, at least in Java, where this is mostly because for the long time we didn't have a proper API to handle dates. Now we have, and we have this idea of locality, of local date. Like, people start to have discussion like never ever use local dates because they are bad, because they don't have the offsets and zones. But sometimes I don't really care about the offset and the zones. I just care about local time, which I call, damn it, I've lost some slides. Sorry. Sometimes I don't really care about the time zones. I just care about the hour or the timing that where I am. So let's try to convert this weird date. So we have this XML. It was a SOAP XML. So we have this concept of date time in the SOAP messages, and it gets converted to XML Gregorian calendar, so the calendar API, which we know from Java. The problem we are facing here is that whenever we look at the clock, at our watch, we look at the local time. We can refer to it as a wall time, as a time we have on a wall. So very, very, very local. It is represented by the UTC with time zone shift, but we don't really care. We care, when it comes to buses, we care that the bus is coming at 7:20. We don't really care that it's coming on 6:20 Zulu time, or it's coming at 6:20 Zulu +1. This is very local, like where I'm here. So let's go on with the conversion. So we have this weird date. We get the calendar, we get the instant. Instant is the number of seconds from the epoch. From the Zulu time, it gives us a number, and then we try to convert it with some Java API. So we take local date time, a date, a number of seconds, and then we have to put a time zone because we are somewhere, and Java requires this API. So we said that we are in Europe also, which is one of the standardized time zones, and get the local time. So now it's time for a quiz. What will be the output of this call? Will it be 7:20, as we have there, or it will be 7:44, or it will be 6:20 because it's converted to the UTC and then shifted to Warsaw time, or it will be 5:20 because we are in the summertime. Any ideas? We can do voting. We have a little bit of time. So who is for 7:20? Nobody. Okay, a few people. 1, 2. 6:20? Okay. 5:20? Yeah. 7:44. Okay. You are for 7:44 because it's totally weird and you suspect it's the right answer. Damn it. Yes, it's 7:44. Why? Okay. So that brings us to another false assumption, that what is the time zone for Europe Warsaw? We all know it. It's Central European Time, UTC +1, unless we have daylight saving time, which is 2 hours, UTC +2 hours, right? It has ever been since. Well, it has been here as long as most of us live, because it has been like this since 1977. And before that, it was just UTC +1 hours. You can ask your parents. There was no daylight saving time at some point. And then through some point, there was again UTC +1 and so on. And then there were some different differences. And then there was UTC +124 in like 19th century and at the beginning of 20th century. So it makes perfect sense. We had an 1899 as a year, so Java just took appropriate time zone, which I appreciate, and converted the time as it should be converted, right? Right, you know? So that brings us to another false assumption, that time zone rules changes, and they change fairly often. This is quite a hot topic at the moment because the European Parliament voted there will be no saving time, so we can expect no daylight saving time, so we can expect another change in time zone rules, but it happens very often. If you look around the world, time zones changes a few times a year. Sometimes it's well announced, like in Europe. Sometimes it's pretty much not announced at all. For example, like 10 years ago, Libya dropped daylight saving time, and they announced it 2 weeks in advance. You know, how long does it take for your system to do a feature? And then sometimes the changes are very significant. There are these Samoa Islands on the Pacific, which are just at the date, how we call it, damn it, the date change line, let's call it like this. And they were UTC minus 11. But most of their business, most of their operation as a country was done in Australia and China. So at some point, they decided that they don't want to be UTC minus 11, they want to be UTC plus 12. So they skip a date. That's fine. I think it was from 29th of December 2003 to 31st of December 2003. That's all fine. We should be expecting things like this. So this is not the corner case. This is normal. So if the time zones change frequently and we don't want to think about it, maybe there's a different approach we can take towards time in our systems. So let's go to the conversions back. So we want to do it the right way. So we just take the string format and parse it, and that's fine. Though it sounds a bit uglish. Maybe we can do it a better way. So let's get back to our example. One of the rules of the game should be to keep the dates or keep the timing idea within your systems as simple as possible. Like the simplest, the better. For example, the last example is one thing, the birthday. I was born on 2nd of January, regardless of the time zones. If I happen to go to Australia, and it will be a 2nd of January, I'll celebrate my birthday, because I will think only about local time. I will not care about being born in Poland in a different time zone. I don't care. So as simple as possible. So if we get back to our buses example, we have this 3:48 as a timing information. So should we keep it like this, or maybe we can keep it as the number of minutes since midnight? Because the timetables pretty much start every day, aren't they? Well, kind of. So maybe you can just keep the duration information within hours from the midnight, because that can help a lot. And after the next day, we have a next timetable. The way timetable works in most of the systems is they are announced in advance for like a period of time, like 2 weeks or 4 weeks, depending on the size of the city and the size of the fleet. And it just every day the same. So we don't really care about the date information, we care about timing information. The problem with the buses and with the timetables, and it's again a very contextual thing, is that a day within the transportation system is not 24 hours. It's 25, 27, depending on day. Because we just cannot put local time in there. Because if we put 3:48 as a local time, then it might happen that the same bus will go on 4:26, so the next date, but still on the previous day's timetable, because it's a night bus, and it starts at midnight and finishes its route at the next day. That's why they kept this date information, but we can just keep the duration. If we just keep the number of seconds since the midnight of the day the timetable starts, we can still do the conversions. So we can still capture the information about timing. So we just can store it as a long, being an example. And then we have in Java this time information, and then we can do conversion. We can do the duration. We have a timetable for a particular day, and then we can have an exact timing of the bus. That will work. As well. So another takeaway. Some people say that, well, it's all bullshit. Just store in UTC. Well, you can, but it's not always. It's not always wrong thing to do, but it's not always the right thing to do. What I try to do is just keep the least possible information I need, and don't care about the others. Because as you've seen, somebody just put a year, or just didn't care about the year, and the year information suddenly appeared in the system, and it's the root of many different problems. So If it scratches your brain a bit, the presentation is available, and there is a bunch of links you can follow and explore. There was a very good presentation in Polish by Tomek Nurkiewicz about time zones a few years back, and there's an awesome, really awesome source of all the falsehoods, including dates, which you can look up as well. So if you have any questions, you can shoot at me, or I'll just go to Slido and see what we can do about that. Right? Right. No questions. Okay. Any questions? It's a lightning talk. It's just 15 minutes. Is storing duration from valid for last Sunday of March or October? Meaning the changes in the daylight saving time, right? Probably yes. Well, it all depends. I think the context is much wider. And this problem is pretty much frequently solved by the company itself. For example, trains just stop for an hour when it's daylight saving time, when they are going from 3 to back to 2 at the end of March. Some other companies just delay everything by an hour. So it just depends. It is. I don't think it's. I think it's valid because it still refers to local time. When we shift the time, it's shifted, and we just keep the difference between the midnight. So if the difference is 2 hours, it's still 2 hours. So it just depends. Okay. Thank you very much.